this, and you know, the earliest where the scientists, of course, Arrhenius talked about. There's a paper by Arrhenius which talks about coal and CO2 and the impact of CO2 way back before the 1900s. But really speaking, in early 1950s was the first time that the climate change problem was thought about. And since the 1970s, the Intergovernmental Panel on Climate Change has been started. So it's only been 70, 80 years when we've been looking at climate change. However, we have a record of, so we've not been monitoring the CO2 concentrations in the atmosphere, but nature has provided us this record. And how has nature provided us this record? So we have these expeditions going to the Arctic or the Antarctic. And in these expeditions, what happens is, you take out, you can see this is the expedition, and you take out ice cores, this core of ice, and as you go deeper and deeper, the depth is related to the time when the ice was formed, right? And you can have you can get the date based on the depth. At the time when that ice was formed, we have had trapped air, which represents the composition of air in that year. So nature has provided us this frozen record, and if you just Google, nowadays in the classroom, students don't listen to the faculty. There are the kinds of curves, right? And this is, on the y-axis, is the concentration of CO2 in the air, right? What is the main composition of in air? What is the main composition? Nitrogen, oxygen. CO2 is relatively small, okay? CO2 is actually parts per million by volume, okay? That's the remaining. And what you find is, if you take the first 800 years or so, you find this is a process. If I get a graph like this, many of you are in statistics and you just do a regression, you put a straight line through it, you'll see there's a band. It's a process under control. Process under control with 280 parts per million by volume, natural equilibrium, plus minus 5. Then what happens? This feature of this curve is like a straight line. This curve is an exponential growth curve. What happens? What changes this? What has changed this? Yes? Industrialization? Industrial revolution. James Watt and the steam engine. Okay, let me now take a diversion. We'll come back to this graph again. Conscious of time. We'll come back to this graph again, but we'll go back and we'll go back into history and look at this is a precursor, John Newcomen's steam engine. What happens? Burn coal here, generate steam, run a piston, have a reciprocating thing, you convert it into motion, use that to mine, you start mining materials, that's the whole process of making goods and services and products. And this is the Industrial Revolution, and James Watt went into it. Incidentally, at that time, in industry, what was being used? The horses. That's why you have horsepower. He used to call horsepower. So he actually, James Watt was also a businessman. He said, we will leave a steam engine free of charge to you. We will install these and we will take over for 5 years the customer service. Remember, this is in the 1700s. We guarantee you that the coal for the machine costs less than you spend at present at fodder on the horses which do the same work. And everything that we require of you is that you give us a third of the money which you save. Professor Valera was talking about saving 60 lakhs from the solar PV. James Watt saying, I am giving you a steam engine free of cost, and you give me a certain percentage of saving, and this was but that started the use of coal. Then you had coal mines, and then you had coal-based power plants. And I'll show you some images quickly. I'm going to I'll share all these slides, but I'm not going to go through all the slides. This was the first plant, Edison's plant. It was a DC power plant. Okay, in the heart of Manhattan, New York, Pearl Street plant, and this was the location. These are some images. They had a generator, and he got the news heading in New York Times. It was the first time we had electric lights and 52 light bulbs in the New York Times office. At that time, they actually had a tariff. Initially, it was only lighting. And then what happened is the electricity used only a small proportion of the time. So they actually gave a tariff to induce people to use electric motors. And you get cheaper electricity if you're using electric motors. And that was the next. These are some details of 110 volts and 99 about 100 kilowatts each. That's a very large equipment. This was the kind of thing which is there. And you can see that initially when it started, it was all traditional biomass. Then you had the steam engine, then you had the electric motor, then you had the automobile engine, then the vacuum tube, commercial aviation, television, nuclear, and internet. And you can see how energy use in exajoules, 1 exajoule is 10 raised to 18 joules, has been growing exponentially. And the mix has also been changing. It has been basically, initially it was mostly biomass, renewables, and then it started coal, oil, gas, and then nuclear, and then essentially fossil fuel became the main contributor for human development, for rapid prosperity. But in the process, what we started doing is we started increasing our CO2 usage, and that has come up with a problem, and we need to move back towards renewables. We go back to this plot, and of hydrogen. They release energy. If you look at C plus O2 giving you